Hello and welcome to Macroeconomics. We're putting together the short-run model. How do macroeconomic shocks affect the economy? And what can we do about them? Let's go back nearly 80 years. William Phillips developed a rudimentary hydraulic model of the macroeconomy, a physical machine. It linked interest rates, trade, investment, GDP, and other things, all together in a circular flow. Literally, the water flowed. They called it the MONIAC. That stood for Monetary National Income Analog Computer. Let's take a look at it.
It's one of the first macroeconomic computers. It was built in the 1940s. So this machine here is going to show how water flows around the economy or how money flows around the economy. We have this income tank down here, and this is water flowing up into the machine as income. Before the income reaches households, some of it is taxed, and for the government, this is income. So taxes flow down here as income to the government. Then the government decides how much it would like to spend. The income that is after taxes, this is where it reaches the households, and the households have a choice to make. They have to choose between how much they'd like to save and then what they don't save, they consume. How much a household saves will depend on the level of interest rate in the economy. In this investment fund here, which helps determine the level of interest rates, this will also determine how much investment firms undertake. So if we add these three components here up, this is our domestic part of the economy. So we've got government spending plus consumption plus investment. And this adds up to domestic expenditure. So the way all this water flows around.
The model will explicitly link interest rates with the spending savings decision. Just as the IS curve, the investment saving curve, in our version of the model, links real interest rates with the output gap. Now she's going to conduct a simulation. The economy is running hot. There's too much inflation. And so the central bank is going to raise interest rates. In our model, this would be increasing the MP curve to slow down spending.
The level of GDP down here is very high, so the economy is running a bit hot. So what we're going to do now is we're going to drain money from the investment fund. So this is tightening monetary policy. So when there's less money in this investment fund, so we're going to see the level drop, which is just like seeing interest rates rise. So money is now more scarce. So what you can see on this chart here is the interest rate is increasing, and it's increasing rapidly. These slides here show how households and firms react to changes in the interest rate. So this bottom bit here, shows how much do firms cut their investment when interest rates increase. This one up here shows how much do households stop consuming when interest rates increase. Over on this chart over here, this is GDP. There hasn't been much of an effect, but this is something we would expect to see. The flows go around the economy and it continues having an impact for some time. It takes time before monetary policy has an impact on the economy, which is what we see in the real world.
It's a really neat hydraulic computer, and while it's highly simplified, they still claimed an accuracy of plus or minus 4%. So not super precise for forecasting particular numbers, it is good enough to get the direction and relative magnitude of the variables. Modern models, of course, use software and are far more complex. The Federal Reserve's primary model has nearly 400 equations. They model a host of responses for consumers, determine labor hours, wages, prices, business investment, and all other sectors of the economy, incorporating their expectations about the future. In the model we're building in this series, we're just going to have three curves. Nevertheless, it's a pretty powerful way to organize cause and effect in our macroeconomy. On our top axis, we have the real interest rate and the output gap. The IS curve, or investment savings curve, represents all of the aggregate spending, the aggregate expenditure. That is consumption plus investment plus government expenditures plus net exports. And there's a downward sloping relationship between the real interest rate and the output gap. The monetary policy curve, or the MP curve, represents real interest rates. Where do they come from? You start off with the risk-free interest rate set by the Fed, you add on the risk premium coming from the market, and you get the interest rate represented by a horizontal line of the MP curve. We intersect the MP curve and the IS curve to get the output, and then we can bring it down to the Phillips curve to give us the inflation rate. Notice our axis here is netting out the unexpected inflation because we recognize there's three causes of inflation: unexpected inflation, demand, and supply. Moving along the Phillips curve represents changes in demand, and that links to the IS curve showing changes in spending patterns. And then shifting the curve will represent changes in the supply, changes in costs or productivity of producing things. We get the output gap from the intersection of the MP and the IS curve, bring it down to the Phillips curve, and that tells us what the interest rate is. It might help going through the sequence of events in some words. We'll start off with the Federal Reserve, the country's central bank. They set the real federal funds rate, the FFR. This is the risk risk-free interest rate. And specifically in the US, this is the overnight loan between two private banks. Well, then we go to the financial market. All of the financial suppliers and demanders determine what the risk premium is. We will add this to it, and that gives us the MP curve, the overall interest rate for the economy. Then we take this real interest rate, and it's going to influence spending via the IS curve. We take the amount of spending in the IS curve, that gives us an output gap. Now that we have the output gap, we can link that to the unexpected inflation via the Phillips curve. And then we add in inflation expectations to give us the overall inflation rate. And that's our model. There we go. We did it. Okay, let's practice it. We'll start off with the federal funds rate being 5%. The risk premium is 3%, meaning the overall interest rate is 8%. And at a real interest rate of 8%, we plug that into the IS curve, and we note that the economy is performing slightly under potential, say negative 0.5%. We continue to use that output gap, bring it down to the Phillips curve, and that tells us the unexpected inflation. In this case, unexpected inflation is slightly below, we'll say negative 0.7%. And so what does that mean? If expectations are normal, that's at 2%, that means that overall inflation is equal to 2% minus that 0.7% of the unexpected component to give you an overall inflation rate of 1.3%. And there we go, we did it.